Alright, for this word problem here, we're told that the sum of two numbers is 26, and the sum of their squares is a minimum. Find the number. So it doesn't look like there's a lot of information given, but there actually is a lot. It can be a little bit confusing to try and set up, though. So first of all, we're looking for two numbers, right? So let's try and set up let statements for them. Okay, so there we go, and again, nothing too fancy. Let's just let A and B be those two numbers. So we're told that the sum of these two numbers is 26. So now that we've defined our two variables, we can say this means that A plus B is equal to 26. Okay, that might become useful at some point. And this is the key part right here. It says the sum of their squares is a minimum. Okay, well, what's the sum of their squares going to be? So it's going to be, well, first of all, the squares means to take the power of 2 of it. So it means they're going to have a squared and b squared. And it says the sum of their squares is a minimum. So it's going to be a squared plus b squared. And we need to call that something, right? So let's just call it, I don't know, s for sum. It can be absolutely anything, right? But this is what we're trying to make a minimum. And the moment you see the word minimum, you're thinking something to do with the vertex. Now we're trying to find the numbers that make this a minimum. So we don't care what the actual minimum value is, just what numbers make it a minimum. So we're looking for the actual axis symmetry here. Now the problem again here is we have too many independent variables. We have A, we have B, so we can't actually work with that yet. But we do know that A plus B is equal to 26. So we can use this information over here to eliminate one of the variables. So what we're going to do is isolate for one of the variables from here. So I'm going to isolate for A. So A is going to be equal to 26 minus B. Okay, so now I can replace the A in the other equation with that. So I'm going to wind up with 26 minus B all squared. And then again, plus B squared. Equals, again, I'll just call it S. So this is the equation I would need to try and find the minimum of. Okay, I need to find the values that make it a minimum. But again, it's not in any kind of form I'm used to working with. So what I'm going to do here is I'm going to expand everything out to put it in a standard form, and then I'll see what I can do from there. So when I expand everything out, remember 26 minus b all squared is going to be 26 minus b times 26 minus b. Okay, so I'm going to expand that out using an array, using the distributive property. Okay, by now I'm sure you should be a pro at using an array to expand and simplify. It's a big skill going forward after grade 10. So remember, every cell the array gets is filled in with multiplication. So 26 times 26 is 676. This is going to be negative 26b. Another negative 26b here. And negative b times negative b is simply just b squared. Okay, so this becomes, when it's all expanded out, b squared minus 52b plus 676, and then this plus b squared, which was there originally, equals s. So you collect all your like terms together, you wind up with 2b squared minus 52b plus 676. Okay, so from here, again, I'm trying to find the value of b in this case that makes this entire thing a minimum. So I'm looking for the axis symmetry, and again, with all the things we've looked at from standard form to try and find the axis symmetry, completing the square, partial factoring, probably the fastest way I showed you was to use that whole trick where it was x equals negative b over 2a for the axis symmetry. Okay, now again, you have to be careful here because x is an independent variable here. It's actually b, and this a and b refers to the coefficients, but that was the whole idea. So fastest thing to do here is probably just say the axis symmetry is going to be equal to negative 52, so negative b, all over 2a, and a is 2, so 2 times 2. Okay, you can solve for that. Again, remember this is the axis symmetry. So you get 52 divided by 4, which is equal to 13. So when b is 13, the sum of the squares becomes a minimum. So with that in mind, now that you have b, it doesn't just want the answer, one of the numbers wants both numbers. So if a is equal to 26 minus b, we can sub in what we know and that the fact is that b equals 13, so that means that a equals 13 as well. So two numbers are going to be 13 and 13 to make the sum of the squares a minimum. Okay. So let's take a look at the next one. So here we're told a rectangle is 3 centimeters longer than it is wide, and the diagonal is 15 centimeters. Find the dimensions of the rectangle. So first thing we're going to do here is just sketch out the rectangle. It's always a big help. So there's our rectangle. And we're told it's 3 centimeters longer than it is wide. So let's just label our width here. It's going to be W. And the rectangle is 3 centimeters longer than the width. So if the width is just W, the length is going to be W plus 3. Okay, so we should define our variables here, so I'll make sure to write out a let statement. Okay, so here's my let statement there, so let W represent the length of the rectangle in centimeters. So that's just me drawing out the rectangle and recognizing that since it's 3 centimeters longer than it is wide, if the width is W, the length is going to be W plus 3. So next thing that we're told is that diagonal is going to be 15 centimeters. That means that this length right here is going to be 15 centimeters. So it says find the dimensions. So again, always be looking for some keywords here. You don't see, you're being asked to find the dimensions here, so you're being asked to find W and basically the length as well, which is W plus 3. But you don't see the word max or min anywhere, so you know it's not an optimization, probably not looking for the vertex. We're told the diagonal is 15, so let's take a look here, and is there any way we have of relating the sides of the triangle with the diagonal? And the answer is yes. If you look here, we have a right triangle, and we know the three sides of a right triangle are always related to each other using Pythagorean theorem. So we can say from this that that squared plus that squared is going to be equal to 15 squared. So let's put that into an equation here. So we're going to have W squared plus W plus 3 all squared is going to be equal to 15 squared. Okay, and that's an equation that we can solve. Okay, there's only one variable in it. It's a quadratic equation, and we can solve any quadratic equation by, once everything's expanded, getting it all equal to 0, and then either factoring using quadratic formula. So let's expand everything out, bring it all to one side, use our standard quadratic problem solving, or sorry, quadratic equation solving strategies, and just use those here. So I'm going to have W squared, W plus 3 all squared. You can expand that out using an array using distributive property. I'll trust you do that on your own. You should get W squared plus 6W plus 9. And 15 squared is going to be 225. Okay, so when I collect all your like terms, bring everything together on one side. So I have 2W squareds here, so I get 2W squared plus 6W. And then subtracting 225 from both sides, I get minus 216. Okay, so from this point on, you have standard form on one side, 0 on the other side. Your options are factoring or quadratic formula. I always believe that factoring is faster. However, if you're stuck and you're having trouble factoring, you can use quadratic formula to get the solutions in this point. But I'm going to see if it factors, because I think that's always easier, and it's always good practice. So I'll check the discriminant to see if it does factor. So b squared minus 4ac is going to be equal to 6 squared minus 4 times 2 times negative 216. Which gives me 1,764. Is it a perfect square? I'll check. It is. So that means this does factor. So I'm going to go through it and do it with factoring. If you prefer to use quadratic formula, feel free. We should wind up the same place in the end. So what I'm going to do now is I'm going to first look for a greatest common factor, which I can see is going to be 2. So I get W squared plus 3W minus 108. Okay, so to factor this, it's a simple trinomial. So I'm looking for two numbers that multiply to a negative 108, but add to positive 3, and that's going to be 12 and negative 9. So that's going to factor into w plus 12 and w minus 9. Okay, so I'm going to give you my, so from here I can get two possible solutions. So from here I get w is equal to negative 12, and from here I get w is equal to 9. Now before I go any further, I always have to ask myself if my answers are valid. Does it make sense that the width of a rectangle giving me negative 12s? And hopefully that jumps out at you as being impossible, because you can't have a negative width. So this is going to be what we call inadmissible or invalid. Okay, and why? Because you can't have a length that is negative. So that means my only possible answer will occur when w is equal to 9. Okay, so if my width is 9, I now need to find my length, and I can see that my length is going to be w plus 3, so my other side is going to be equal to 12. Okay, so my two side lengths are going to be 12 centimeters and 9 centimeters. The thing you always want to watch out for here is, again, make sure you always check to see if your answers are valid within the context of a problem. So if you wind up with a negative answer for the length, it usually is not possible. Okay, you can't have a negative length for a rectangular field. Okay, so your two answers here are going to be 9 centimeters and 12 centimeters. 9 centimeters for the width and 12 centimeters for the length.